Good evening. We'll wait for a couple of more minutes for students to join and then we'll get started. Hi, good evening. Before I share my questions, if you have any queries that you want me to discuss, we can get started with that. Or maybe we can wait 2 more minutes to see if someone else will join and then we'll get started.
Durga Prasad for final exam, watching videos will be sufficient.
If you have gone through the lecture videos and you're thorough with the assignments, that should be sufficient. The level of exams will be as close to the assignments as possible. In fact, 50% of the questions will be same as your assignments.
Okay.
I think we'll get started. So, are there any, okay, apart from your assignments, like as I mentioned, for your exam, the questions will be very similar to the assignments that you have been solving. So, they will be at the similar level. So, you can prepare from there. So, apart from that, you have any other queries that you want me to address? If not, there were some questions yesterday on, actually some of them requested to see some demo code for PIN. So, I'll get started with that. Before getting started, if you have any queries, let me know. We'll go through them first and then we'll go to the code. Yeah, I guess there are no questions. And maybe I'll get started with, I'll just share my screen. I hope my screen is visible. So the main objective of showing this code is just to tell you where to exactly keep in your pin loss function. That's the main objective. Other than that, you don't have to worry about TensorFlow or PyTorch or any of that stuff. So it's like a very simple problem, very small differential equation. You have a 1D heat conduction problem, Laplace equation, d square t dx square equal to 0, and the boundary conditions are as follows. At x equal to 0 you have 1, and x equal to 1 you have 0. Let's say this T is some kind of normalized temperature. So the analytical solution is given by this, T of x is 1 minus x. Now if I want to fit a neural network to it, you can decide what the values of W and V are. So this is quite straightforward. The only difference that comes here is how you define your loss function. So inside the loss function, usually we would be having the y minus y hat square, but in this particular problem I do not know the actual solution beforehand, like T of x equal to 1 minus x is an analytical solution and I am not using that information. All I am trying to do is approximate this T of x with a neural network and then try to find the weights of neural network in such a way that it will solve this particular governing equation along with these boundary conditions. Okay, so is there any question, like someone is saying something? Okay, I guess nothing. Okay, so the model is very simple. So you just have a linear combination, so wx plus b, that is the first layer, and the final output is given by another layer. So we have just two neurons, first layer followed by second layer, so w1x plus b1, and then you pass this. I am using a linear activation function here, I am not using any tangents or anything, so you don't have any activation here. So you just pass it to the next layer and from there you directly get your output. So very simple architecture. The only difference is in your loss function. When you define your loss function, now you need to come up with how to calculate your d square u dx square. How do I do that? TensorFlow, or for that matter any of these frameworks, usually have automatic differentiation. So somehow if I can calculate this d square u dx square, then I can just get the loss function from there. Loss function is essentially square of your d square u dx square. And then I also need to consider my left and right boundary conditions. So in order to get the left boundary condition, whatever model I have trained, I'll pass the left condition, that is x equal to 0 and x right is x equal to 1, and from there I get those values, and I know my boundary condition is at the left side it should be close to 1 and on the right it is 0. Those are the boundary conditions that are specified. Total loss is the loss for your governing equation plus your boundary conditions. So from there you get your total loss. Training loop is again straightforward. This is a TensorFlow of way of saying how to calculate this automatic differentiation. You can just consider this as like a boiler template code or something, so you don't have to worry much about this. The main point here is like yesterday someone pointed out, so you don't have to actually have any training data to use your pin. So if you see, all that I have provided here is just the governing equation and boundary conditions. I do not have any training data for this particular network. So I've just chosen some sample points x from some uniform distribution initially and then use those points to train my network directly. So the loss function will be your governing equation loss plus your boundary condition loss. That's the only thing that I have been using. I have not used any data as such. And then you run for a specific number of epochs, and then once error reaches a certain level, I just plot it and see how well it matches with the predicted. And actually this is a very simple scenario. The only point here is how you include your how do you update your loss function. That's the only difference between the traditional one and this particular problem. This is a very fairly straightforward problem. Let's take a little bit complex one. Let's say you have the fin problem that we discussed yesterday. The governing equation goes as d square theta dx square So for the fin problem, I have fixed the value of m, that is the fin parameter here, and then x I have chosen some random variables. Instead of choosing from 0 to 1, this is the non-dimensional x depending on your length. So this is basically x by L that I have been using, and then instead of taking the entire domain, I have just taken from 0.3 to 0.8. This is just to illustrate that pin acts as a regularizer and that is it doesn't actually overfit the model. So I'll train both the normal neural network without pin loss and with pin loss, and then see how both of them actually perform with each other. Why is actually I've used the analytical solution for an adiabatic tip. You have this is the analytical solution for this particular problem. Plus I've added some normal noise to generate some synthetic data. So once I have this, rest of it goes straightforward. You don't have to go into the details of it. The only difference comes here, just as we did before. In your loss function, you have 3 terms that needs to be added up. One is with respect to your data. I have some training data, so I can use the training data as well. Second is with respect to your governing equation losses. So you somehow calculate your d theta dx, and from there you theta x is basically d theta dx, and then from there you calculate theta x, and then you add this governing equation theta xx minus m square theta, that is the governing equation for a fin. And similarly you also calculate the boundary conditions at left and right boundaries and add them. So this is how your loss function looks in a pin. If you're not using any pin, your loss function is just the data loss. So what I wanted to compare here is essentially, if you see, this is an additional term that we are adding here, which is like your regularization that we have been discussed before. So I'm just going to show some results. So this is the loss is close to around 10 power minus 4. This is without any pin. When I do the same thing with a pin, it has a little higher loss, but if you happen to see the loss on the data, just on the data, it is close to 10 power minus 4. These are the additional losses because of your boundary conditions and your governing equation. So when I tested this, I tested on the entire domain, that is from x equal to 0 to 1. So when I do the testing, so if you happen to see, the training data is only from 0.3 to 0.8. In that particular region, ANN is actually fitting reasonably good. But when I tested it on the range that is not being trained on, then this is actually deviating much farther from the original one, which means that this is what you call overfitting or underfitting. Which one is this? So it has a good accuracy on the training data, but when I tested on something different, the deviation is much larger. Do I call this overfitting or underfitting? Overfitting. So the other one is with respect to pin. So pin is actually kind of doing good even on the data that it has not been trained on, which means it has overcome this problem of overfitting. Now coming back to what the network is. Yesterday we discussed a few other networks as well. I've used a TANH activation here, but then I've tried with even few other activation functions as well. TANH ReLU, we kind of discussed this yesterday, so I'm not going over the same thing again. How do you decide your activation function? Yeah, the main point that I want to highlight here is pin actually works as a regularizer, and it will actually kind of help you to prevent your overfitting. These are the main 2 points that I want to highlight here. These 2 points are clear. There was a question yesterday, so I'd just like to go over that again. Before actually going to the problem, are there any other questions that you want me to answer? Because this is something different from the course content. So if there are any other questions, maybe I'll take them first and then we'll get into this. Yeah, I guess there are no questions. So yesterday, one of you, I think the person is not here in today's session. Yeah, the question was essentially on how do you do a regression problem using an RNN. Let's say we take a projectile problem. I just took a very simple example so that you can, this is just for an illustration purpose. So let's say you have this particular problem of a projectile, and then you want to kind of estimate your y. So basically you can have 2 different scenarios. Let's say I have trained this particular whatever RNN I use on certain portion of the projectile, and I want to forecast for the remaining region. So after doing some normalization, which is a little bit of math that you would be able to do later, I'll upload this on Drive, so you can go through that. The relation between y and time is essentially 4 times t minus t square. So one way to do this is use any of your regression model. So which models would you suggest? So can I use so if I know that this is the relation, so which kind of models do you suggest? If I have t as my input and y is the output that I want, can I use SVM? Or maybe linear regression? Can I use linear regression? With whatever that is discussed in the course, if I want to use linear regression for this problem, will I be able to do it? Or maybe should I put a question in a slightly different way? I want to use linear regression. How do I use it for this problem? Yes, basically you change your basis function. So now you have two features. In addition to 2, you will also use t square, and from there you will fit the model, and then you get the values of 4. That is one way of going about it. But now let's say that since it is a time series data, so usually for time series we go with RNNs. So let's say I want to use an RNN. Let's take a very simple case. I want to use a vanilla RNN. Vanilla RNN is like you have one hidden layer, x is your current input, yt is your output, ht is the hidden layer output for at that particular time step t. So these are the relations that you have. Here I kind of used a linear activation, so that otherwise you would be having an activation function here. So in addition to this, you will have something like some activation functions here. I kind of use a linear activation, so you don't have to do much calculation here. So for this particular problem, what do you think the values of u, v and w would be? This is straightforward, so you should be able to do it with hand calculation. So how do you prepare the data set in the first place for a time series data? So I have some time and some y values. So let's say I have t equal to 0, I have some y value, and so on. And I want to do a forecasting problem. So how will I prepare my training data? Assume that this y is already normalized between 0 and 1, so you don't have to worry about normalization. So for all of these RNNs, there are again two classes, so one to many or many to one. So which one of these is it? Is it a many to one problem? Or many to many? Or let's put it in terms of MATLAB, sequence to sequence or sequence to point. So what I mean by sequence to sequence is your input is a sequence. So let's say y0, y1, and then up to so yt is what I provide as input, and my output is also going to be a sequence. Let's say it will be something like y1, y2, one step ahead of whatever is provided, or sequence to a point where you have y0, y1, so on, and it just predicts for the next time step yt plus 1. For now, let's say I am restricting to the second case. I give my sequence as an input, and then I predict my yt plus 1, and I am saying that I will use a window of size 2. Sequence to point, but for future time instance. Yes. So how do I get the values of this w, u and v if I were to do the sequence to point with a window size of 2? So let's say if you have just two y0 and y1, let's just take one instance of your training data. So this will be your input. Because I set a window size of 2, so y0 and y1 will be your input, and your output will be the next time step y2. So this is what you will be doing for your input and output mapping. So what is it now that is required? I need to find this u, v and w from my RNN. So how is my y2 calculated? y2 is essentially v times h2. What is xt? So what will be my xt? T2. Okay, any other options? One of you said it is T2, but my input is only y0 and y1, right? So where does this t suddenly come into picture? When you give time series as input, all I am saying is I am just provided this y. This is basically the index of that particular array. I do not have the actual timestamp values. So like I said, the input is just y0 and y1 is what is provided as input, and y2 is my output. So what should be the value here? Is the question clear? So I have given the expression already here. So based on this, what should be the value that should come here? Okay, first let me make it clear. Is the question clear? So when what do we get when we unroll a neural network or RNN? So we have y0, y1 as my input. So there is some neural network here that predicts an h0, and this h0 will be used again h1, and then you finally get your y2. This is what we are doing in an RNN, right? Maybe from this you should be answer now. What should be the value that should come here? y1, yes. Now similarly h1 is given in terms of, here you just have two of these things. Maybe I should stick to the diagram. So if you see the diagram, y2 is v times h1. There is no h2 in the diagram, so I will stick to that. So h1 will be w times h0, u times y1, and h0 is again, you don't have anything here, so this term goes off. So you just have u times y0 plus b. One more point that you would like to note here is this w and u are kind of shared weights that will be same across different time steps. One of you, I don't remember who, but one of you actually asked this question even in the discussion forum, that what about these w's and u's? These are the shared weights, very similar to your CNNs. Even in CNN you have the shared weights in your kernel. The same idea has been extended in this RNN. Okay, now that you have these values, so how do you calculate this y2? What am I trying to do here is essentially put it in some format that if you can recognize. So all I am trying to do here is write y2 in terms of the previous time steps plus some constant. You might have come across this previously somewhere else if you recollect one of your finite difference schemes. Most of your finite difference schemes will be in the similar format. Let's say if you are using central difference scheme, or let's say backward difference with 2 time steps, so you'll have something like this is a projectile where the governing equation goes like d square y by dt square is minus g. So all I am doing this is writing this in this particular form, yt plus 1 minus, basically doing central difference at yt. this is kind of very similar to the expression that you happen to see here. Instead of t, you are having 2, 1, 0. So basically your y2 is written in terms of y1 and y0. From this you have just 3 constants and 3 unknowns, so you should be able to find the values of v, u and w directly. You can also use gradient descent and solve this problem. That's up to your choice, but I've tried this, but you can try gradient descent, but that would actually take much time to converse. This would be straightforward. The point that I would like to highlight here is using an RNN, what is it that you are trying to do is approximate this particular form. You know that all of this is essentially following this particular equation. So you are trying to capture these relations using your RNN. Now let me put a question slightly differently. So this is with respect to RNN. So can I use LSTM here? Or let's say, can I use a tanh activation in the same RNN? In this particular example that I have chosen, I have used linear activation. Can I change the activation to say tanh? Okay, anyone who says no? Okay, let me put this question slightly differently. We discussed this even yesterday as well. So what is the range of output that you are trying to find? What is the range of output of y that you are trying to model here? And what is the range of tanh? If you use tanh, what is the range of output that you would be getting? So let's say I normalize my y to 0 and 1. So basically y, the output essentially belongs to 0, 1. Yeah, for tanh it is -1 to 1. So if you use tanh, essentially half of that is not being used for. And it kind of saturates it. So if you have something like this, so after a certain point it kind of saturates both at -1 and 1, and you won't be actually needing half the entire portion of it. So you actually have to, the network has to force the weights in such a way that most of it only falls in this particular region, that too only in this particular region, because it doesn't want a constant function. So you have to learn weights in such a way that you are forcing to use only certain part of your activation function, which might not be a good idea. So maybe you can use a ReLU, or if you use tanh, you have to actually change the way you give input to your network. Maybe you come up with a different kind of normalization so that this falls within -1 to 1, so that you completely use the entire domain. Okay, now let me ask a slightly different question. So this part should be clear by now, that what we are trying to do using RNN is essentially find some fundamental thing like this, and we try to do some discretization. This is just one idea, but ultimately you will be trying to find something fundamental that is spanning across different time steps. so that in order to forecast your future, you use this information from the history. Now, let's say the thing that is already been discussed previously is when you have very large time steps, then you have something called vanishing gradient, and then this method fails. So in this particular context, so let us see here yt plus 1 is given in terms of g times delta t square. So if you, to those of you who are familiar with finite difference schemes, this is just a second order approximation, so you know the error goes with delta t square. So if I choose a very large delta t, let's say the time somehow maps between 0 and 1, and then in steps of say 0.1 versus 0.01. When you have a very small value of time steps, what do you think the forecasting error will be? Small error for small time step. So what happens if I use the same thing to keep going on again and again? So what I mean is I've just taken a window of size 2. So all I will be doing is, so I'll start with y0, y1, I'll forecast y2, I will use y1, y2, and then forecast y3, I'll use y2, y3, forecast y4, and I keep going on doing like this. What will happen if I do this for much longer steps? The forecasting, this is very similar to your finite difference schemes. If you use a method with, like if you are doing forward marching and use a very large time step, what would happen is eventually your errors will accumulate, and then you will completely diverge from your solution. So essentially, if this is my actual value, this is how I want it to be. But when you train your network, what happens is, because of these steps, you initially will be in the right track. Okay, you'll initially be in the right track, but after a certain point, you'll actually keep diverging from your original solution. One way to prevent it is actually reduce your this particular value. So this is also straightforward, so I don't have to stress much on that. Yeah. I'm not sure if the person who asked the question yesterday is available in today's session. I see. Okay, he's not here, so maybe we'll not go through this. But otherwise, you can actually check the documentation of LSTM on MATLAB website itself. They actually provided an example where you have a periodic data set, and then they train an LSTM model on that to do the forecasting. Since he's not here, I don't want to go through that particular example. Yes, accumulating error is something that you cannot fix without changing your delta t. You actually have to use a data set that has a very closely aligned space points, or the other way is to actually increase the depth of your network. So that way, what you would be trying to do is, instead of using linear order or first order interpolation, you will be using a much higher order interpolation. So basically what I mean to say is, now I have used a single layer RNN here, so just this particular one. So now what I would be doing is, in addition to this, I'll put one more network here. So this I'll connect to another RNN. So when you increase the depth of your RNN, you will kind of use some higher order approximation. So that way you will kind of, with the same time step, you will be able to capture much better. But you won't be able to completely eliminate it. It's very similar to your finite difference schemes. There's a limit to how much you can go. Is that clear? The main purpose of LSTM is slightly different from this. So if you happen to see, the reason why LSTMs or GRUs are provided is to help you when you have long time spans. So essentially when you have data like this, let's say you have a sine function. So let's say this is your horizon. So if you have something like this, and if my window length is this particular one, and if it has say 100 steps, when you want to forecast into the future, you need to come across all these previous time steps. So say suppose if you want to predict at this particular point, your whichever architecture you're using, RNN, LSTM, GRU, whatever, should be able to remember that similar point, depending on your time period, there exists a point here, and it should to take the value of this here. In order to do this, it should remember this one, which means you need to train with 100 steps. So your error should back propagate through 100 steps, which doesn't happen with the simple RNN layer because of your vanishing gradient problem. That's where LSTM comes, or even GRU comes. So if you have this much larger time steps is what they'll support to. That has nothing to do with the one that we discussed before. That's a different problem. The one we discuss here is not a periodic problem. Is it clear? Yes, we would not know this prior. That's exactly why we do not know which architecture will give you the right result. You keep trying with different architectures, and then one of them will actually give you a better result. There are some other networks that actually give you this governing equation as well. If you come across, I don't know if any one of you have come across those architectures, but there are some architectures which actually try to generate differential equations. If you have gone through the pin, you might have done the reverse way. So basically from the data, they will try to give you the differential equation. All they try to do is a slightly different way. What they try to do is approximate a differential equation, let's say of this particular form. And then they try to find these A, B, C and D values, and then see which of these values will actually dominate. When one of these values is close to 0, then they eliminate this and they finally come up with their governing equations. That is another way of doing, but then how do you actually find the right architecture to determine A, B, C and D is again empirical. You have to kind of test it out. So let's leave that aside. So okay, so these questions are taken from this particular paper. This is on generator adversarial networks, or GANs. They are used. The main objective here is to predict the flow field for a given geometry of your airfoil. The workflow is straightforward. You have some input data representation, and then you choose a model, and then you finally do the validation. But for now, the question here, okay, there is something wrong here. I'm not able to erase this off. Yeah, but I think it is clear. So we have discussed this yesterday also. So the input geometry is kind of given in this particular way to the network. So which kind of representation is this? Is it a binary map or a sign distance function? It's kind of very obvious. So you just have zeros and ones, so it should be binary. So we discussed yesterday as well. So because of being binary, you have these irregularities here. So in order to get a smooth boundary, you can actually use the sign distance function. This particular paper uses binary map. The problem with the sign distance function is it's a little bit more expensive than binary map in order to generate it. So they kind of avoid that problem. So what are we trying to do here is we provide this particular geometry as input to my network, and the output that I want here is the velocity field at every other point inside this domain. Basically wherever there is 0, I need to replace that 0 with the actual velocity field there. Let's say I'll have two images, one for u and one for v, basically one for horizontal velocity component, vertical velocity component, x and y components. So that is my objective. And I have chosen that I'll use a CNN for this particular purpose. Basically I have an input image, and then I want to get a velocity fields as my output image. So my input is an image and output is an image. So which architecture do you think should be suitable for this particular application? A UNet or an LXNet? Okay, maybe you might have forgotten the exact names of the architectures, but just to kind of if you recollect, so LXNet is basically used for classification purposes. So your input will be an image, but output will be a number between 0, 1. So you cannot directly use this. UNet is somewhere where you have image to image kind of a network. So UNet is something that you will be using here. However, it's not exactly UNet. You need to, because UNet is primarily designed for segmentation purposes, you need to kind of change the last layer in such a way that will suit for this particular application. So the last layer should be changed to get velocities. So what this particular author have done is they are using a GAN type of approach, where maybe I'll show you the architecture first. So they will take the image, and then they'll also take some of the problem parameters like say Reynolds number, and the angle of attack is basically at which, the angle at which your fluid strikes that particular airfoil, and then use this to pass into the, this G is basically my unit, and then they'll get a mark. Mark is basically the output of the unit, so they are essentially getting some features from it. With this they will generate some fake structure, and then they'll also have a ground truth that is generated from your CFD simulation, or whichever simulation, whichever software you use. You have the actual velocity field. If you already have a data set, is good. Otherwise you simulate for this particular values, and then you get your ground truth, then you train the discriminator. This is very similar to whatever is being discussed in the GANs. This is kind of some refression, just to refresh your concepts on CNNs, a few questions. So this is the architecture they have used. So this is only the part of the architecture. So in UNet you have two components, an encoder part and a decoder part. So this particular architecture that I have shown here is only for the encoder part. So once you have the encoder, then you again instead of this convolution filters, you will have transpose convolutions, and then you have your okay. Do I have skip connections in UNet? So basically UNet has, you have an encoder architecture. So you start with a bigger image, and then you keep reducing, and then you keep on increasing. That's it, or do I have anything else? So if you recollect, we also have something called skip connections. Basically you have some connections here, so that the gradient information flows backward, because when you have very deep layer, the gradient can actually vanish. So you have to provide alternate paths. So there will be one more connection directly between the deconvolution part and the original part. So that way you actually allow information to pass directly from here to here. So these are called your skip connections. So we have that in UNet. Okay, let's not go into it. Okay, let's do some little more calculations here. It's a very straightforward calculation. So if this is the convolution filter that I am using, and this is my input size, 128 by 128 by 1. One is for the, I just use a grayscale image. So the input is just the binary map. So it's a grayscale image, 128 by 128 resolution. So convolution filter is this. I have 64 filters, and stride is 2. So what will be my output shape? So let's say I'm using 1 by 1 padding all around the surroundings, all around the boundary. Yes, it's right. So you have so this is essentially your number of filters will actually come in the last place. Okay, so let's say from this 64 by 64, if I use a 4 by 4 convolution filter, and let's say this is my output shape, what should be the padding? So how do you calculate that? The output of my convolution is related with input through, or some relation. Maybe you can give me that relation. So what padding size will actually give me this output? If you just know this relation, you should be able to directly calculate all of them. S is a stripe, K is my kernel size, P is my padding, N is the input size, M is the output size. So I've given M as 32. You have padding of 1 by 1. So everything is straightforward. If the next one is basically the reverse, so you have input of 32, so N is given, padding is given as 1. So the output can be calculated directly from this relation. Stride is given as 2, K is given as 4. So these are straightforward calculations. Okay, let's do this one. So how do I calculate the number of parameters? So the transformation is from 8 by 8 by 256 to 4 by 4 by 256 using this particular convolution layer. 256 filters, stride 2 and a kernel of 4 by 4. How many parameters will be there? So how do I calculate the number of parameters? Only for this particular layer. So I use a 4 by 4 kernel. I have 256 such kernels, stride 2. So how many weights will be there? So each kernel is basically your matrix. So how many elements will be there in a matrix of size 4 by 4? So you have a matrix of size 4 by 4 that will give you 16 elements. So you have 16 weights that you have to learn for each filter plus one bias term. And how many filters you have? You have 256 filters. So this should give you the total number of parameters. That's it, or is there something else? Yes. How many channels are there? So how many channels I have? From the previous layer, I have 256 channels previously. Yes. So you need to take into that as well. Or is there anything else, or is it that's it? That's all. So these are your number of weights plus your bias times number of filters multiplied with your number of channels. That should give you total parameters. The same thing for the last one as well. So these are straightforward calculations. Okay. Let's say I want to train this network. I need to come up with a loss function. So what is the loss function that I will be using here? With the inputs that I have shown here, with whatever notation I am using here, what will be the loss function? If I am just using a GAN, what will be my loss function? So I have to do a minimax problem. So I'll minimize something, I'll maximize something. Then I have to do something, discriminator probability. What is the input for my discriminator? Basically all I do is take binary cross entropy, just that my instead of probability I'll use the discriminator. Discriminator is essentially giving me the probability. So there will be a log. I'm just ignoring a log for now. The question is which one is minimized and which one is maximized. Yeah, g of z, instead of z I am writing it as x1 and x2. So this particular work has actually used something called x1 and like they have used two things. X1 is the geometry and x2 is the flow parameters. So you need to consider both of them. So I'm just writing the two values here. Okay, so which one is maximizing, which one is minimizing? So basically you can have something like you minimize the discriminator, maximize the generator, or the other way around. So which one is it? Let's say this is A and this is B. What does the generator do? Does it maximize or minimize this loss function? Okay, so one of you says it's A. Any other options? Like any other one who says the other one? See, what discriminator tries to do is it tries to differentiate this well. This d is a probability that it actually does it right. So what does the discriminator try to do? Does it try to maximize d or maximize 1 minus d? Which one is it? Is the question clear? So it's straightforward. Is it A or B? Which one of them is right? Only one of you has actually given an answer. Yeah, I have not written log here, just to kind of, there will be a log here. Let's leave that aside for now. B. Yeah, you have actually answered. I am just seeing if others actually. So, is there any challenge with this particular portion, or? Okay. So, basically, what your generator tries to do, the generator tries to maximize the chances that your discriminator will fail. So, I'm just phrasing the question slightly differently. So, D is the probability that that particular, say if y is passed, D is the probability that it is real. Discriminator, whatever the output of the discriminator is between 0 and 1. If it is close to 1, it means that it is real. If it is close to 0, it means it is a fake. That is the one that we are trying to do with the discriminator. If that is the case, what is it that the discriminator tries to do? It maximizes this. What does the generator do? It will try to fool it, so it will try to maximize this one, the other component, which will essentially mean minimizing this one. So it's a second option. In addition to this, do you have the question also says that if I want to have one more regularization parameter, what else could I do? Is something add like this, where you have y is my ground truth minus whatever I have generated from this. So maybe I can add something like this. This is something very similar to what you do in your variation order encoder. This is your reconstruction loss. So basically whatever that is being generated by the generator, I'll also do this particular error, so that this can act as a regularization. So whatever output that is coming from your generator will be close to the ground truth. Lambda is actually the value that you can choose to put pressure on your optimizer to go in whichever direction it wants to. Let me just write it on. The next was is on autoencoders. This we already discussed before, but just to recap. But before going there, are there any other questions? Because a few more people joined recently. So are there any questions that you have? Okay, I assume there are no questions. So when we discussed on PCA, so let's say I have a problem like this. Let's take a simple problem. So for those of you who are familiar with fluid mechanics, let's say you have a pipe flow problem. So you have some velocity, you have some, or let's say a channel flow, the one we discussed yesterday. So you have two parallel plates separated by distance h, and u is your velocity. So what are the problem parameters? You know, if you know the velocity, essentially you do it the average velocity. Instead of u, you have some u average, you have h, and you know the fluid property. Let's say you have some fluid property. So these are some parameters that you have, but you know that the entire problem is only governed by your Reynolds number, which goes in some way. So what you have done here is essentially from 3 parameters you have boiled down to just one parameter that will define your problem. So the question now is, can PCA do this? We discussed the lecture videos discussed on PCA. So what does a PCA do? So when you have a very high dimensional data, let's say with n features, after you perform PCA, you essentially reduce the dimension from m such that m is less than n. This is what you are aiming to do in your PCA. Can PCA do this kind of transformation? No. Why? Because the reason being PCA captures only variance. Okay. Yeah, so basically if I have a training data that has different values of u average, different values of h, different values of mu, and then say I predicted the flow field somehow, and then won't I be able to do this? Like maybe you can elaborate a little, because it captures only variance. Maybe you can elaborate on the statement a little. Yeah, basically when your features are non-linearly correlated, PCA won't help. Why is it? Because what PCA does is it tries to find your eigenvalues and vectors and then come up with new features as a linear combination of your eigenvalues and vectors. So all you would end up is finally this xm will be some linear combination of your whatever your previous features are there, and this is essentially not a linear combination. So PCA won't be able to capture this directly. So that's where you come up with what people have tried is use. We'll not go into POD, but people have tried using autoencoders, where in variation autoencoder you can actually your neural network can actually do something like this. So you have an architecture where you have 3 features as your input, and then you have an encoder to one latent space, and then from there you actually reconstruct it. This is what you do in an autoencoder. So since neural networks are able to capture these non-linear features, it should be able to come up with this feature, which PCA won't be able to do directly. So in VAE you have 2 kinds of losses. One is your reconstruction and your KL divergence loss. Now let me ask this question. I don't know why this is, I'm not able to erase this. Okay, but what people have done is in PCA, whatever components you get, they are orthogonal to each other. So they are kind of independent in some sense. But when you do this with a variational autoencoder, how do you ensure that they are orthogonal to each other? So which of these two terms do you think will ensure that they are orthogonal to each other? Or none of this will actually give you any information as to that? So what I am trying to ask is you have a latent space here where you have certain number of features. Let's say from 3 to 1 is what I am trying to do. So instead of one feature, let's say you have two different features. How do I ensure that both of these two features are orthogonal to each other? Or basically they are independent from each other. Is there any way to do that? Does BAE do that with this particular loss functions? Okay. So what does the first term do? Reconstruction loss essentially tries to ensure that the output of your VAE is as close to your, like once you do pass it through your encoder and decoder, whatever output you get, this should be close to this. That is what your reconstruction error does. What does the second term do? KL divergence. So what does KL divergence do? It ensures that whatever the latent variables you have chosen here, they are following this whatever particular distribution you have chosen as your base distribution. Say in this case, if I use a Gaussian, it will try to ensure that it follows a Gaussian distribution. So this is essentially where I can kind of give input to my particular model, saying that whatever features that you have in your latent can actually be independent from each other. So if you have the covariance matrix of this Gaussian distribution, I can ensure that only diagonal elements are there and everywhere the elements are 0, which means that whatever latent space is there, all these features are independent from each other. But in order to do that, all that I have to do is when I am training this particular VAE, I should ensure that more weightage is given to the second term than the first term. This we have discussed before when we are dealing with gradient descent. How do you give more weightage to one than the other is essentially when you just use something like your regularization. So you just put some constant here, let's say in beta VAE they call it a beta term, where the value of beta will be actually little higher. If you choose it to be 1, then it is a VAE. If you choose value greater than 1, then your gradient descent will try to find the weights in such a way that it will give more weightage to KL divergence term than the reconstruction term. That way will ensure that whatever latent space you have will actually be will follow this particular distribution where you have only the diagonal terms, so that you have independent features. Then the problem would be that your reconstruction error could actually be little higher. So since your gradient descent is not focusing more on this error could actually be higher. So training this is a little difficult, but the idea goes like this. This is clear? Maybe I should use a different color. That is exactly the idea that was used in this particular paper. I have not provided the reference here. I'll add the reference a little later. So they actually tried to use VAEs for some reduced order remodeling, and they kind of found out that beta VAEs are actually much better than the normal POD method. We'll not go into details. The only point that I would like you to take away from this is this second term here that was discussed in the class is to ensure that it follows a particular distribution. If you want any of the features that you want for the distribution in the latent space, you have to ensure that have been taken care into this particular P term. So if you want independence, you kind of provide these terms to be 0. If you want some other feature, you accordingly change your probability distribution here, and that will ensure that the weights are chosen in that particular way. That is the main takeaway that I want you to take from this. These are the questions that were asked for me in the last few sessions. So one is on RNN, one is on GAN, and one is on VAE. So that's it from my end. If you have any questions, then we can discuss them. Yeah, I'll keep the forum open for discussion for those of you who have any queries. If you do not have any queries, then feel free to leave the session. Can VA give functional form of the reduced order model? By functional form, I think, okay, you mean to say that something like this, if these are my input, it won't give me this. No, it won't. There are some architecture, maybe I can show you that a little. Maybe can give you reference for that, so those of you who are interested can actually go through it. So this is on, this was derived for dynamical systems, where the idea is to essentially generate the governing differential equations from your like the question that you asked. So I want a functional form. Usually I would be needing the functional form instead of some approximation. So if you have some function like this, so what does, say if I use some neural network, if I just use a neural network with say ReLU activation, so what happens is when you have several units, each unit will give you some form of a ReLU function, so something like this, the other one gives you something like this, something else give you something like this, and when you combine all of this, you eventually get something like. So basically all you try to do is you approximate this somehow. So most of these neural networks will only give you something like that. So this will be approximated with some way like this, or some other higher order approximation, but then it won't actually give you the actual functional form. So what people have done is, in order to get the functional forms, they try to do it something called, I just can't get the name of that, but the idea goes like this. So you essentially assume that there is a basis functions. So you come up with some basis functions, something like say sin x or x, or let's say polynomial basis function, like we do in a regression case. And then you come up with the weight vector. This weight vector will be trained in the usual way like you do in your regression problem. So this way you can get the functional forms. People have tried something like this, or instead of polynomial basis function is a very crude way, but then people have tried with other basis functions, say Legendre polynomials or something. So to those of you who are familiar with heat transfer problems, you know that Bessel functions or something, that will, most of the heat conduction problems will end up there. So if you use a basis function with Bessel, then you would be able to do it. So people have tried with other different kinds of basis functions. So from there you will be able to get some functional form of it, but none of these models are not that interpretable, the way that they will directly give you Reynolds number. So regarding boosting, okay. So what is it? Or each of the weak learners, I mean basically you are calling them weak learners because they are high variance. Essentially they are overfitting, so that's why we're calling them weak learners. So if you are having a high bias model, which means that is the training error itself is not good enough, right? So basically you have very high training error in the first place, and there is no point in combining all of them. You can actually improve the model and then make it the training error less, because you already know the training error is high. So what is the point in using that again? The idea in boosting is this. So you know the training error is less, but then somehow when you try to use that model on new data set, it is not working well. So what you do instead is develop so many learners which do very well on your training data, and then do some ensemble of all of their outputs on your testing data. Hope you got the idea. Is it clear, or maybe I should give an example or something? Yes. Okay, so what you, okay, I got it. So what you are trying to ask is how do I know that it is a high variance model? Okay, it is maximum residual of the previous, and then you keep, okay, you are referring to that boosting, not the ensemble one. Okay, 1 second. But even then, if you have a very high bias model, so how can you improve the bias of it? Yeah, maybe I'm not the right person to answer, but I'll inform the correct person, and then maybe I'll put it in the discussion forum. Yeah, I'll get back to you in the discussion forum. But the logic was still the same. But if you know that your model is already underfitting, you can definitely improve it. It's overfitting is actually the problem that you cannot improve without more training data. Still, I'll get back to your question after discussing with the concerned person. So are there any questions from the assignments that you want me to discuss other than assignment 12? Since they are simple decision stumps. Yeah, if you are just in that particular case, there might be high bias because they are just single layer, like single node decision trees. Okay. No, you have, think you have received a mail now as well. There is one more session on, I think maybe tomorrow or Tuesday. The usual one, the weekly sessions happen. There are 3 weekly sessions that are happening. One on Saturday, one on Monday or Tuesday, I guess on Monday, and the other one on say Wednesday or Thursday, I don't remember. So there are 3 sessions actually. So the other session will be happening tomorrow. Not by me, but another person will be taking that. Yeah, there is one more session tomorrow from 6 to 8. The sessions will be ending on 18th April. There won't be any sessions after 18th. sessions. Okay. Initially, actually, there are 3 sessions happening. So one on Thursday, usually it happens on Thursday or Friday. I think they kind of discontinued it a little later. The drive has actually 3 sessions being uploaded every week. Yeah, I think the logic goes with you. So when you have simple decision sums, then they could actually be high bias since they are very simple. But since that you are training on your residual, eventually they'll get better and better. The one I was referring to is in an ensemble method where you use many weak learners. So that is where you have high variance. Okay. Right. The mail ID is already there, I guess. If not, I can just send you my mail. You can reach out to me on my mail. If you want, you can comment in the YouTube video as well. But better if you just send me a mail. Yeah, if there are no questions, then maybe we can conclude the session for today. Then tomorrow you will have one more session from another instructor. So maybe if you have any doubts, you can ask there as well. What if I could not submit 8 assignments? I mean, the deadline is already over. So you have already submitted. So are you appearing for the exam? Okay. So I'm not actually from the admin part, so I do not know the actual process of it. So I'm not sure how many assignments you have to actually pass to write an exam or something. You can check that in the website or put it in the discussion forum. The admin will actually respond to such questions. If you have any specific queries inside the assignments, you can ask me. No. The exam will be very similar to your assignments, the one that you are solving now, the weekly assignments. MCQ, it's same as your weekly assignments. It will be MCQ, no descriptive, you don't have to do any coding, no coding will be there. So it's just like your assignment problems. come for the exam, it's the lecture videos and the assignments that you have to go through. Those will be the part of it. The questions that we discuss here are only to help you understand the course. They won't be part of your exam. That even if we discuss something extra from the lecture videos, these are not going to be part of the exam. The ones that I've discussed extra are because some of you have actually asked questions in the previous sessions. So it's only for them because I'm recording this, so they will get to see later once I upload the recorded part. But other than that, they won't be part of your exam. Yeah, I guess that's it. If there are no further questions, then maybe I'll end the session for today. So I provided my mail ID, so if you have any questions, you can reach out to me on my mail ID, or you can also put it in the discussion forum. But I'm not actually monitoring the discussion forum, it will be done by someone else. And you have a session tomorrow as well, so you can ask your queries even in tomorrow's session, the concerned person who is available there. Thank you all for joining, and all the best for your exam.